Okay, welcome to another video on electromagnetic field theory. I'll be solving the second question of quiz 1. We'll continue from there. Now let's look at the questions. All right, quiz 1. The second question, we have, this is quiz 1 of the first group, right? So quiz 1A, transform the vector. So this is a vector that we have here. Vector Q giving us 3 along the direction of the radius minus A minus 8 along the direction of the angle of rotation, and then plus 9 along the z-axis. 2 rectangular coordinates at point M. And then M, we have these coordinates. S is equals to 5, Y is equals to 8, and then Z is equals to 9. So we are to transform vector Q to rectangular coordinate system. So we have question 2. Okay. Let's have question 2. Now, when it comes to transforming a vector coordinate from one coordinate system to another, so this time you can see that we are giving vector Q here is expressed in cylindrical coordinate system. So we have, is it 2? Let me get the question right. We have 2, 3 rather. Okay, 3. So we have here 3. Then here is minus 8, right? Along the direction of angle of rotation. Then plus 9 along the z-axis, right? Now that we know this, and we are to transform this to another coordinate system, which is rectangular coordinate system. Rectangular coordinate system is just the same as Cartesian coordinate system. So meaning our future vector now, which is vector Q, we have is going to be expressed in rectangular coordinate system, meaning I have here Q S along the x-axis plus QY along the y-axis plus QZ along the z-axis. So this is going to be our future vector. Now let's get the coordinate AS, AY, and AZ. So when it comes to getting the coordinates AS, what that simply means that it's going to be equal to taking the vector Q, which is expressed in cylindrical coordinate system, dot of the unit vector along the x-axis. So we get this. When you replace everything, that means we replace minus 8. Then we have plus 9 dots of what A is. So this will give us 3 minus 8. Okay, we are doing the dot product, so let me bring dots here. Okay, AS. Then plus 9 along the dot of what? The dot unit vector along the x-axis. So we get this. Now this is our QS. Now let's continue. When it comes to now, we have to now find the dot product of what? AR and then AS here, the unit vectors. So how do we get this? So the table there is given, you can use it. But from experience, right, that we solve question, we know that AR, right? AS. So how do we, meaning you can just sketch something of this nature. I can sketch my x-axis here. Then I have my y-axis. Then we know that the angle we have here what as these are the unit vectors. So let me indicate here the unit vectors that we have. Okay, here what unit vector along the x-axis. Along the x-axis, rather. Let's make here S. And this is a unit vector along the y-axis. Right. When it comes to now, we are going to now have unit vector along the direction of the radius. And then the angle between that and then the unit vector along the x-axis is phi. Now with this, you can see that if you're having the dot product of AR and AS, is simply going to what? Cos, right? It's going to the magnitude of the unit vectors, the product of the magnitude of the unit vectors. So since they are both unit vectors, meaning each one is 1, the magnitude is 1. So 1 times 1 will give us 1. So we have here, then times cosine of the angle between them. The angle between unit vector along the direction of the radius of the cylinder and then the unit vector along the s-axis is going to be, the dot product will give us cos phi, right? So we get cos phi here. Now we have minus, this time we have unit vector if we have a phi. So how do I get a phi here? Unit vector a phi. So to get this, what that means, we are going to increase this. And then we know that since a phi and then a they are both unit vectors of cylindrical coordinate system, what that means that the angle between them is going to what? 90 degrees. So I can come, just make something like this. I have my a phi is here, and then meaning this angle between this, we assume it's 90 degree. So we have this, right? Now that we've done this, if we are now finding a phi as, so you can see that it just goes, if here is 90 and then here is phi, meaning from a s to a phi is going to what? 90 plus phi. So we have 90 plus phi. So our half here is going to be cos. So I can write here cos 90 plus phi. And then we do the last one. Here is just what? AS, AZ, right? AS. I mean, these are also unit vectors of cylindrical coordinate system. So as a result, the angle between them is 90 degrees. So their dot product is going to be what? 0, because cos 90 will be what? 0. So here will be 0. I can further simplify this part here to be 3 cos 5 minus 8. Cos 90 plus 5 is going to be what? So how do I get cos 90 plus 5? I want to change this into, or we can even leave this, right? You can leave this like that. Later we get phi and then we can use it straightforward. Or if you don't want to do that, we try and see how, if I have, for example, 30, then I add 90 to it, that is what? 120, right? So if you have cos 120 is going to be minus 0.5, right? And that's 0.5. So if I take sine, 30 will give us what? Okay, sine 30 will give us positive. So if I want to, I have to get here negative. So here will be the same as negative sine phi. Yeah. So we get something like, we can even check here. Let me get this straightforward so that we'll be sure. So you can see that A phi, AS. So you get minus sine phi. So it's correct. That one is correct here. Now plus 0. Okay. Now let's try and get phi, right? So when it comes to getting phi, we are going to be using the point M. We have been told that we have to transform this at point M. So meaning at point M, we have S equals to, let's see here, we have S being 5, Y is equals to 8, and then Z is equals to 9. That means, in that case, if we know the coordinate and I want to find phi is going to be equals to tan inverse of Y over S. So that means tan inverse of Y, which is 8 over 5. So 8 divided by 5, then tan inverse. So we get here to be 57.99 degrees. That is our phi. So you can see that now I can replace phi in the equation that I have above, so that we get 3 cos 57.89 degrees. Here we would minus you get positive 8. Okay. 8 here times sine 57.9. So what do I get? So we get 3 times cos 57.99 plus into bracket 8 times sine 57.99. So that will give us 8.37. So we get 8.37 for the S coordinates. Now let's get QY. QY2 is also going to also take the vector dot of the unit vector along the x-axis. So this one we can do straightforward. This one is going to be equal to 3 AR dot of AY minus 8 A5 dot of AY plus 9 AZ dot of what? AY. So this will give us 3. So again, we can come and use this diagram that I have. So if I have AR, AY, where is my AR? AR here, AY. So you can see if yes, phi, and then the whole of this is 90 degrees, right? So that means the angle between AY and AR here will be what? 90 minus phi. So I can write here. So that means we have cos, which is 90 minus phi. Then I have minus 8 A phi AY. Where is A phi AY? A phi AY. Here the angle is going to what? The angle, this angle here, which is going to be this angle, is going to be the same as phi. So here will just be cos phi. Then plus, again here 9 we have these are unit vectors of Cartesian coordinates, so we get 9 times 0, so here we 0. Now let's look at, see now we can even use this straightforward. So if I have cos, we have 90, I can just even use, we already know 5, so I can just use straightforward. 3 times cos, when I have 90 minus 5, which is 57.99, minus, I guess, 8 times cos 5, which is 57.99. So we end up getting minus 1.696, which is just the same as minus 1.7. We're making minus 1.7. Now let's get the last coordinate, which is QZ. And this one, again, the same method. We take the vector, which is expressed in cylindrical coordinates, dot of what? The unit vector along the z-axis. So this one, you get dot of what? AR dot of AZ minus A phi dot of AZ plus 9 AZ dot of what? AZ. So when it comes to the dot product, again, AR and then AZ are both unit vectors of what cylindrical coordinates so system. That means their dot product will give us 0. So we have here 0, this one too, again 0. Then we just have a unit vector dot of itself, you get 1. So here will just be 9. So our vector, which is going to be expressed in Cartesian, will be 8.37 along the x-axis minus 1.7 along the y-axis plus 9 along the z-axis. So we've come to the end of this solution. So I'll see you in the next video. Bye-bye.